Okay, exercise 5D. Well, we're going to be looking at the area of a sector, so we're going to look at where we get this equation for the area of a sector from. We're going to start with what we know from GCSE, and then we're going to think about changing the variable to one where the angle is measured in radians. So I'm going to use this symbol to represent radians. Now the fractions of the circle expressed in radians and in degrees are the same fraction, they're the equivalent fractions, so we make them equal. And what we notice is that we can replace theta over 360 by phi over 2 pi, and then if we do that, the pi's cancel. And we're left with just the angle times the radius squared times a half. So the starting point for any question where you're finding the area of a sector in radians, you are going to be using this equation. First of all, we need to find out what the angle is inside the minor segment sector. And that is going to be 2 pi, take away the 5 radians outside. Finally, we square the 8 and half it and expand into the bracket, and we get our answer in non-calculator form. Okay, that was a really basic example, like the first few from the exercise. Okay, in this question, we're asked to find the area of two segments and to add them together. So the first thing we do is we put in a radius to our third corner on the triangle. And if we do this, we actually get an angle at the centre is double the angle at the circumference. So 0.5 becomes 1 at the centre. We can figure out all the other angles nearby if we need to. And we do need to. Pi minus 1 is the other angle at the centre. Now what I'm doing here is I'm finding out the area of the whole segment here, and that's what this is. And I'm taking away the area of the triangle that we don't want as part of the area, and that's what this is. We're using half AB sine C. Now, that's going to be effectively my final answer for now, before I reach for the calculator. Next, I'm going to find my second area, which is the smaller blue area around the corner. But again, it is a segment, so I'm doing the same thing. I'm finding the area of the sector, and then I'm taking away the area of the triangle. Having a really well marked diagram obviously will really help you recognize what the angles are and so on. And finally, we add these two things together. Okay, so that's a basic two examples. As you move through the exercise, you'll find circle theorems appearing and other subjects appearing in these questions. So you might see right angles between radius and tangents. You might see tangents of the same length touching the same circle, or a right angle in a semicircle. We've already just seen the angle at the centre being double the angle at the circumference. So you're going to see these coming up all over the place Be prepared for them. You don't need to quote your circle theorems, but you do need to use them.